All right, welcome back to your favorite Fundamentals College Math class. We're going to take a look at solving equations. And here's our addition subtraction property of equality, right? If you have like 3 equaling 3, if I add 1 to this side, I got to add 1 to that side to make sure that they stay equal. Or if I subtract 2 from one side, I got to subtract 2 from the other side, right? The addition subtraction property of equality. Multiplication property of equality. If I have 3 equaling 3, if I multiply this side by 2, I got to multiply the other side by 2 to keep it the same, right? That's the multiplication property of equality. Similarly, if I divide both sides by something. So we're going to use those, right, to solve for x here. If I have 10 plus x equals 14, I'm going to go ahead and do the opposite. This is a positive 10, so I'm going to subtract 10. If I subtract 10 from that side to isolate x, I got to subtract 10 from the other side. And of course, I would have 14 minus 10 gives me 4. And the beautiful thing about mathematics is you can check your answers most of the time, right? 10 plus x equals 14. If x really is 4, is the statement true? You bet it is. 14 does equal 14. So we love that about math. We can check our answers, right? Let's look at this next one here, b minus 9. So I'm going to do the opposite of that minus 9. I'm going to add 9 so that b is all by itself. If I add 9 to that side, I got to add 9 to the other side. So b ends up being negative 12 plus 9, negative 3. And of course, you could solve or isolate that as well. Sorry, you could check that as well. Let's do the next one. 2/3 k equals negative 4. Now we want 1k. Kind of like this one we did just right before. 1b was what we have. We just don't write the 1 there, do we? But we want a 1 in front of the variable to have it be isolated. So how could I have this be a 1k? Well, if I multiply this by its reciprocal, you see on that side, if I do it to that side, remember I got to do it to the other side. But see how I would have 6 over 6? 3 times 2, I'd have 6 over 6k. I'd have 1k. So that's why we multiply by the reciprocal. We got a fraction right there. We go ahead and multiply 3 halves to the other side. So I got negative 4 times 3 is a negative 12. 1 times 2 is a 2. Negative 12 divided by 2 is negative 6. Why don't you guys try this problem right here? Go ahead, pause the video and try both of these. All right, on this first one, you should have subtracted 3 on both sides. And so you'd end up with negative 10 minus 3, negative 13. Here you've got 4/5 r equals 2. Go ahead and multiply by that reciprocal 5/4 both sides. And see how you got 20 over 20r, so 1r. And over here I got 10 over 4. Now both of those, 10 is 5 to 4 is 2 times 2. So this ends up 10 over 4 is just 5 over 2, right? I'll add one more in. Let's say we got 3x equals 18, and we're solving for x. I would divide by 3 on both sides because I know 3/3 x is 1x. I'll divide on 3 by both sides, and I get x being 6. Now let's get into some multi-step equations. So we're going to simplify this. So again, we're going to isolate the variable. So this first one, 5 equals 2x plus 7. The first thing, one time I've had it explained to me this way. 2x plus 7 equals 5. If this is you in high school, now I don't recommend this, you're throwing a party, your parents don't even know about it, they're going to come home. Are you going to get rid of the girlfriend that's hooked to you first? Or are you going to get rid of your friends first? Oh, you're getting rid of your friends first, right? So get rid of the friend first. The last person you're getting rid of is the girlfriend, right? And then parents are coming home, got to get rid of the girlfriend. Got to go. They don't know you through the party, right? I don't know what that is, but one way to remember it, all right? Now on this second one here, B, if you can combine like terms, then you better combine the like terms first. Notice this is a 1p, and that's 2.2p. So 1p plus 2.2p, it's like 1 apple plus 2.2 apples. 1 plus 2.2, 3.2 apples. P in this case, right? 480. And we're trying to solve for p. So we're going to do the opposite of this. 3.2 is being multiplied by p, so we're going to divide it out both sides. And so 1p equals, and then I just get my calculator out, and that'll give me 480 divided by 3.2 will end up being 150. So p equals 150 on that one. All right, let's do this next one. I want to distribute this first. So I got 2,000 equals 5,000 times 1 plus 5,000 times 0.04t. So we got 2,000 equals 5,000 plus 5,000 times 0.04 is 200t. And this is that same scenario. Get rid of the friend first. Negative 3,000 equals 200t. And now get rid of the 200 there. Get rid of the girlfriend. So divide that out. 200 divided by 200. So I got 1t equals, and I divide negative 3,000 divided by 200. Negative 15 right there. There's our t. All right, let's do this last one here. We got x minus 4 over 2.2 equals 1.85. What I would do here, actually, let me give you a different one. How about x over 3 equals 7? What I would do, remember you want 3/3 x, you want 1x. So what I'm going to do, right now I'm dividing by 3. Let me multiply by 3. Let me do the opposite. If I multiply that side by 3, I got to multiply the other side by 3. See how I get 3/3 x? That's the approach I'm going to take on this one. See that 2.2? I'm going to get rid of it. Right now I'm dividing this whole thing by 2.2. So if I multiply this side by 2.2, I got to multiply that side by 2.2. So I have x minus 4 equals 1.85 times 2.2 equals 4.07. And then I add the 4 to both sides. So I have 8.07. Did somebody point out, I screwed up A. I'm so sorry, you guys. 5 minus 7 is a negative. So I got a negative x. Negative 2x equals 5, and then I got to divide by that negative 2 right there. So 5 divided by negative 2 is a negative 5/2. Sorry about that. Holy cow, you guys, I'm sorry. I'm really screwing this thing up. Forget that. That's all bad news. All bad news. I'm so sorry. I subtract. So this is what happens when you start talking about girlfriends and throwing parties when you actually are a dad of a teenager. It really messes with your mind. 5 minus 7, I got negative 2 equals 2x. Let me write it this way. 2x equals negative 2. I'm now getting rid of the 2, right? So I divide by 2 both sides. So my x is negative 1. And there we go. Don't screw it up. Forget all that party talk. Do the problem right. Sorry about that. All right, let's go ahead and solve for these variables here. 4x plus 3. I'm going to get rid of that plus 3 first. Get rid of that friend. Negative 9 minus 3, I got negative 12. If you want to write that as 4x equals negative 12, same thing. And now we'll get rid of that 4. So let's go ahead and divide both sides by that 4. So I got 4 over 4x, 1x, negative 12 over 4, negative 3. This in here, I'm going to go ahead and multiply that through. 25 times 1 is 25. 25 times 0.03 is 0.75. Now I'm going to subtract 25 on both sides. So I get 375 equals 0.75t. And now I got to get rid of that 0.75. So I divide both sides by 0.75. So 375 divided by 0.75, and I get 500. So now we're going to get into a couple examples with just some applications for solving these equations. So can you set it up and then do the same process, right? I like to guess when I do applied problems. So I like to list my givens, my unknowns. What am I solving for? What are the equations that are given? And then I'm usually substituting, and then I'm solving at the end. So that's kind of just a setup. You're going to read the problem a whole bunch of times, right? And then just kind of label everything. So let's look at this first one. The max heart rate is the highest heart rate achieved during maximal exercise. Generally gain the most benefits and lessen the risk when you exercise within your target heart rate. Usually this is when your exercise heart rate is about 70% of your max heart rate. The formula, I'll write this down, 0.7220 minus A gives the target heart rate T. So this is my equation that they're given, right? This is my target heart rate. I'm going to label this target heart rate in beats per minute for a person who is A years of age in years, right? So those are my unknowns, that A and that T. Those are my unknowns, my variables, right? And I have this equation that's given it to us. So it says determine the age of a person. So I'm solving, right? What's the age of a person? That's what I'm determining. Whose target heart rate is 133 beats per minute. So they're giving us the target heart rate, the T, with the capital T. So we just throw it in. 133 equals 0.7 times 220 minus A. And then we'll go ahead and we'll multiply that on both sides. So 0.7 times 220 equals 154. 0.7 times -1 is a -0.7A. And now I'm going to solve for A. So let's subtract 154, subtract 154. And we get -21 equals -0.7A. Let me take it over here. -0.7A equals -21. And I'm going to divide by that -0.7 on both sides. So my A ends up being 21. Of course, a negative over a negative is a positive. So 21 divided by 0.7 is a 30-year-old. So a 30-year-old has a target heart rate approximately, according to this equation, 133 beats per minute. Now here we've got cost of a college here is given by this equation. C equals 76N, where C is the cost of the tuition, N is the number of credits that you're taking, right? So if you have $800 to spend, let's go ahead and put that in. $800 for tuition, right? That's our cost. $800 we have to spend on tuition. Now, how many credits can we take? Well, let's solve for the credits, right? How many credits can we take? What's our N is the question. That's a really bad N. So let's solve it. Divide by 76 on both sides. And we have 800 divided by 76 ends up being, our N ends up being 10.526315789.5. So we can take at least 10 credits, right? If I take more than 10 credits, I'm going to be out of budget. So I take 10 credits or less based on this so that we're not over budget. Well, thanks so much for taking notes on 3132, and we'll see you guys next time.